Okay, now we're going to wind up with cases where we have an extraneous root. We're going to wind up with a root that we get that doesn't actually work once we multiply everything out. So, step 1, same as it was in the last case. 4x minus 1 over x plus 2 can't be factored. Minus x plus 1 over x minus 2 also can't be factored any further. And then I'm going to say that I have x squared minus 4x plus 24 in the denominator in this case, x plus 2, x minus 2 with the difference of squares. And I'm going to state that x cannot equal positive or negative 2, and that the lowest common denominator is going to be x plus 2, x minus 2. So I have x plus 2, x minus 2 times 4x minus 1, all divided by x plus 2, minus x plus 2, x minus 2, multiplied by x plus 1 over x minus 2 is equal to x plus 2, x minus 2 times x squared minus 4x plus 24, all divided by x plus 2, x minus 2. Divide out, that's going to be gone, that's going to be gone, and those are going to be gone. Which means that I am left with x minus 2 and 4x minus 1 minus x plus 2 and x plus 1 is equal to x squared minus 4x plus 24. I'm going to FOIL out these multiplications of binomials, and I'm going to state that I have, for the first part, the 4x squared minus 9x plus 2. I'm going to subtract from that x squared plus 3x plus 2, and that's still going to equal x squared minus 4x plus 24. Or 4x squared minus 9x plus 2 minus x squared minus 3x minus 2. And when I move the left-hand side over, so I have it all matched up on one side, minus x squared plus 4x minus 24 is going to equal 0. When I combine my like terms, I'm going to state that 2x squared minus 8x minus 24 is equal to 0. Now, because they have a common factor of 2, I'm going to divide both sides of the equation by 2 and just be left with x squared minus 4x minus 12 is equal to 0, or x plus 2, x minus 6 is equal to 0. This means that x could either equal negative 2 or 6. And here's where I find my extraneous root. We said up at the top, x cannot equal plus or minus 2, which means that negative 2 is going to be my extraneous root. We already stated that that is a non-permissible value in this equation. If I go to example B, following the same process once again. Start by factoring the denominators. I have 3x over x plus 2 minus 5 over x minus 3 is equal to negative 25 over, and I'm going to divide this out and get x minus 3 and x plus 2. My non-permissible values are going to be x cannot equal positive 3 or negative 2. My lowest common denominator is going to be x minus 3 and x plus 2. So I have x minus 3, x plus 2 times 3x over x plus 2 minus x minus 3, x plus 2 times 5 over x minus 3 is equal to x minus 3, x plus 2 times negative 25 over x minus 3, x plus 2. Take out the x minus 2 from the first set, x plus 2, x minus 3 from the second set, and the x minus 3, x plus 2 from the last set. And I'm going to wind up with 3x times x minus 3 minus 5 times x plus 2 is equal to negative 25. Or 3x squared minus 9x minus 5x minus 10, and then when I move the 25 over, plus 25 is equal to 0. This is going to state that 3x squared minus 14x plus 15 is equal to 0, or 3x minus 5 times x minus 3 will equal 0. So x can theoretically either equal, x can theoretically equal positive 5 over 3 or positive 3, except for we know from the non-permissibles, there's my extraneous root. For example C, I'm going to solve this by stating that 5x over x minus 4 plus 2 over 1 is equal to 3x plus 8 over x minus 4. Well, I can't factor anything down, so I can just state that x cannot equal positive 4. My lowest common denominator is going to be x minus 4. So if I have x minus 4 times 5x over x minus 4 plus x minus 4 times 2 is going to equal x minus 4 times 3x plus 8 over x minus 4. These are going to cancel out. These are going to cancel out. And what I really have is 5x plus 2 times x minus 4 is equal to 3x plus 8. Or 5x plus 2x minus 8 is equal to 3x plus 8. I'm going to move the x's over and state that I have 4x. I'm going to add 8 to both sides and say that it's equal to 16 and x is equal to 4. And the problem with this is 4 is my extraneous root. And because that's the only solution I got, I can also state there is no solution. If I'm looking for the extraneous root in this equation, I can go through the same process and solve for that extraneous root. And in this case, I'm going to get 5.